Hi, my name is Nico Bimaretti, and my partner Tarun Nambi helped out with this project, but unfortunately he couldn't be here. But our project is SCENT, which is a breath-based volatile organic compound analyzer for early disease detection. And a little inspiration behind the project actually is when Tarun was sharing a story about his uncle who just recently passed away, and he had stage 4 lung cancer, and it was actually diagnosed at the last stage. And that was because his uncle had symptoms, but he was too scared to get testing due to two factors. One being the cost, and two being he was simply afraid. He was afraid of what the testing procedures would look like, what the outcomes would look like. And when he shared that story, it immediately reminded me of my grandma. And she's from a small village in rural India, and she is the most timid lady you'll ever meet. And she is terrified of visiting the doctor because she was heavily reliant on these homemade home remedy practices called Ayurvedic practices. And modern medicine really feels foreign to her. And it turns out my grandmother and Tarun's uncle aren't alone. Over 1 billion people each year have diseases that go completely undiagnosed until symptoms reach lethal stages. And that can be extremely detrimental to their health. So as we were looking into solutions for this problem, we came across VOC analysis using ENO systems. And the way they work is essentially you breathe into a device and it analyzes the breath compounds in it. And essentially using machine learning or any AI modeling, it detects abnormalities in it. And what this is supposed to do is supposed to warrant further investigation for a physician or healthcare worker. And these are super, super cool because they're non-invasive, so they don't require any cutting or any lesions, and they're also painless and time efficient, which is perfect for rural settings. However, there are still some significant limitations of VOC analysis. The most significant limitation is the cost, and this is an example of a very popular one called the Ceranos 320, and that one actually costs around $8,000 if you factor in all the other things such as the technician work and the AI models as well. But in general, VOC analysis systems like ENO systems can cost a lot of money. And our solution is SCENT, which we built right here. And this is essentially our own VOC analysis system. And it's 3D printed with our own array of sensors powered by a Raspberry Pi. And what you do is essentially breathe into it, and it can detect patterns in your breath. And for SCENT's physical design, it is a 3-chamber design where we 3D printed a case, and it has multiple different layers with different components where the Raspberry Pi is hosted stored in the bottom, and the sensor array is on the top. But I think the most important feature is actually the refresh fan in between here, where there's a fan pushing out air. And what this does is essentially cleans the chamber. It essentially purges it in between testing, which allows for the best possible data collection. And this is a circuit schematic. So we use 3 main sensors called the MQ3, the MQ9, and the MQ135, and we paired this with the ADS1115, which is right here. And essentially these sensors are also paired with humidity and temperature sensors, and they capture the human breath microbiome. And the ADS115 essentially translates all that into a language that the Raspberry Pi can understand, where we coded using Python and the ADS115 drivers. And so now that we have SCENT built and ready to go, how are we going to evaluate it, and how can we test it? Of course, due to the nature of the Makeathon, we cannot test on patients with lung cancer or any diseases to be able to detect those abnormalities. So to test it, we had to get a little bit creative. So what we did is on PubMed, we found a data set of 500 healthy control samples, which were essentially they were control participants, and they breathed into the existing ENO systems. And they had all this data of similar sensor outcomes, voltages, where we could directly compare, like an apples-to-apples comparison with SCENT. And with what we did is, me and Tarun are both healthy controls as well, so we breathed into SCENT 50 times each for 3 seconds, so about 3 minutes of breathing. And we would purge in between, so we would turn on the fan and clean it in between each time, and we would get these voltages after we ran our Python code. And we compared that to the 500 healthy sample sets of the healthy participants, and what we're looking for is the data to be very similar, to essentially show that SCENT is able to evaluate the gut microbiome using our custom array of sensors the same as those expensive ENO systems. And we did. As you can see, the data is very similar. It's within the 12% difference, which is the industry standard for when you're talking about VOC analysis. And this is the average of both me and Tarun combined. Then we also measured an augmented breadth. So for an augmented breadth, one of the study also had where participants ate candy, and then they did the VOC analysis using the expensive systems. Specifically, the candy was peppermint. And me and Tarun did the same thing. We had a peppermint and would breathe into scent, and we did the same analysis using our Python code. And as you can see, the data was within the 12% when you look at the averages. And now for a conclusion. So we saw that scent can be a viable alternate to these systems based on the data we collected. Of course, future testing needs to be done, but this shows a really cool example of how we can create a custom array and pair that with our own code to significantly reduce the cost from almost thousands of dollars to $83, which was the cost of scent. And as we saw, the data for the baseline and the augmented breadth was very comparable to those existing eNOS devices, which essentially tells us that scent is able to identify and capture the human breath microbiome as well, or in a comparable manner to those expensive eNOS systems. Thank you.